So this is the case study that we are going to discuss as part of this particular lecture. As you can see, this is the CFD domain. There is a block which is considered to be a indoor ventilation type of a problem. The roof of that particular room is shown here. There is a window on the left, a door that is there as you can see in the front view. Rest are walls, the bottom is the floor, and there is one more window here. So there are going to be solar rays from northwest horizon direction, and the wind is from south to west. So this is the particular internal HVAC problem. The location for this particular case study has been taken as assumed as Mumbai. So the latitude is 18.96 north and 72.82 east. Time zone is about plus 5.5, that is the Mumbai location time zone. A month is considered to be June, and date is 1st of June. And the time for which we have considered the solar ray direction or the sun location or direction is about 2:30 in the afternoon. So this is a type of a worst case scenario that you could have in the month of June. So the solar calculator calculates the sun direction based on our inputs, and this is the results of that particular analysis. The sun direction as shown is from the yellow arrow. We are seeing heating on this particular wall and on the roof, and a bit of a cooler side on the left hand side of our domain. When we see from other view, this is how it looks opposite to the direction of the sun. So the cooler side is actually is in the shade. So that is the result that we are observing. Solar heat flux as shown here. And the temperature contours. So temperature contours are directly an effect of the solar heat that is absorbed. The walls which are in direct hitting which are directly hitting the solar rays are heated up, as well as when the rays pass through a window and hit on the opaque floor, that portion of the floor is having high temperature. Rest of the walls which are in the shaded region or which are directly not in direct contact of the solar rays are comparatively cooler. This is the temperature contour of the exterior surface of this particular room or this particular CFD domain. This is from the sun direction side. This is the hotter side, and this is the cooler side. Internal plane, the walls, the thickness of the wall is getting heated up because of the direct exposure to solar rays or solar heat. The windows space is empty, as you can see. Velocity is primarily because of wind as well as the natural convection effects. So you can see both the effects here at the central plane. And these are the velocity vectors showing velocity currents coming in through the window. There are also some at the bottom as well as at the roof. There are some natural convection currents which are comparatively weaker, but they are still present. As you can see, vectors superimposed on velocity contours. The wind direction as it hits the roof and gets a curve, it can be seen here. Windows through windows, the wind is passing. That effect is also seen. As well as on the recirculation due to natural convection, which is comparatively lesser in strength, but it is still seen here as the roof is getting heated up, this portion as well as this wall surface, and because of that there is heated air is going up, and there is the lighter air going up. That particular current is seen because of natural convection. This is the path line showing how the airflow is there through the windows as well as over the roof of this particular room.